Because I'm not here, I thought I'd leave you some notes. What I expect you to do is find lesson 7, the new packet that you received from me, and use this video to help you fill in or answer some of the questions along the way through the packet. But ultimately, I expect you to be able to complete the packet without any help from me, or be able to use it to help you complete other questions in the future. The first page, we're on page 1 of 46, lesson 7, day 1. The entry task is all excellent practice problems. I will not in this moment talk about them, but you can do so yourself. Turn the page. Let's go to page 2. The last time I talked to you, we had given you notes on what a function is, and I was directing you to the idea that a function is a relationship. It has inputs, which we will and have been calling x. It's a machine that sets up a rule, or it says that there is a way to change x's into f of x's, our outputs. Sometimes an x goes in and it spits out an f of x value, and a different x goes in and spits out a different f of x, or the same f of x value. But as long as anytime this is a consistent value, we will always see a 1 goes and spits out a 2, and later on a 1 goes back in and still spits out a 2. In example 2, bottom of the page, we look at groups. This is one of the ways to represent a function, and I remember that you were able to answer this question, so I'll address it, that 1 always is mapped to D, 2 and 3 are mapped to C. Yes, this is a function because each input, meaning 1 or 2 or 3, always maps to 1 / the same output. If you look at example B, no, this is not a function. 1 goes to A, 2 goes to D, but 3 has arrows that direct it from B and C. 3 could go to either B or C, and there's no rule that says which is which. The function will always send you to the same thing. 3 should always know exactly where it will head. You should not have this choice between two outputs. Going to the next page. Determine if each function represents a relationship, or a relationship represents a function. This is a yes. Even though that 3 goes to 5 and 5 goes to 5, 3 has a definite place where it's going to go, and it's always the same every time. 5 goes to the same number, even though it's split, kind of weird there, but 5 goes to 5 will always be that case. Once again, each input, even though they share an output, goes to the same thing, or is mapped to the same number every time. For the next example, B, you do it. Call this homework. Moving on, down to number 4. If we look at something that's not represented with this groups and arrows that are mapped, we can look at a table. I mean, it's really the same thing. You have a group of inputs, and they are mapped to outputs. So like 5 goes to 10 cents, and 10 goes to 20 cents, and 15 goes to 30, and 20 goes to 40. Yes, this is a function for all of the same reasons that we said before. Each of these inputs only has one potential output. Versus this one, this is your x and this is your y value. 6 days goes to 2, but later on 6 days goes to 5. This is not a function because 6 is mapped to 2 in one spot, and in another 6 is mapped to 5. You can't have the 6 go to 2 different values. That makes it not a function. Let's do this one. So in exercise 5, if you consider rounds as your x's and number of players left as your f of x's, 1 goes to 64 and nothing else. 2 goes to 32 and nothing else. 3 goes to 16, 4 goes to 8, 5 goes to 4. Yes, it's a function because your inputs go to the same thing, or go to one thing and nothing else. You need to do B. B is homework. As we continue down this column, I think I heard you say, and this may be review from us or from years past, about the vertical line test. The vertical line test is a way to check if a graph is a function, if it has a curve, the function is some sort of curve, straight line or not, and you draw a vertical line. This vertical line represents an x value. If that x value, you draw a vertical line and it only crosses the function once, yes, this is a function. Or if it's a straight line and your vertical line, which represents some x value, only crosses the function once, yes, this is a function. But in this curve relationship between x and y, for some x value, there's a y value and another y value and another y value. And because there are multiple y values for this specific input with multiple outputs, this is not a function. The vertical line test is really easy to use if you are able to look at a picture like a graph. In example 7, next page, page 5 of 46. This is a function because for the function that's graphed, this vertical line only crosses, this is by the way x equals 2, this vertical line only crosses the function once at y equals 4. But in the next example, here it is, x equals 2 again, just a good example value. It crosses at approximately negative 3.5 and at approximately positive 3.5. There are 2 y values for one x. That's bad. Okay. The vertical line test uses a random x value, and it can change or shift. We could draw multiple lines, but it uses a random x value as a vertical line to see if multiple y values exist. That would mean multiple y values exist. That would mean that one x has multiple y's, or one input has multiple outputs, and that's not a function. Okay. So please do exercise 2, A and B. Call that homework. I'm going to continue with another video to talk about the next part of lesson 7.